Okay, so now guys, NAT. Okay, it's network address translation. Network address that happens during the ring. Okay, so network address translation. Okay, now don't worry guys, it happens during the ring. Okay, if at all you are feeling disturbed, let me know, we can shift somewhere else. Okay, now so here, now let me tell you what it is. Okay, suppose that, let me draw a figure first. Suppose this is our router, this is our router, home router. Okay, so this is our home router, and suppose this is the computer that, suppose you got two desktops in your home. This is your first desktop and this is your second desktop. Suppose you are connected via, say, wirelessly you are connected to your phone maybe. Okay, now so this is the router. Now let me again tell you, so this connection, or say, let me first draw it completely. So suppose this is service provider, this is the service provider. Suppose you have taken a connection from Airtel, then this is Airtel. Okay, now from Airtel you can connect to the Google, you can connect to Google, so let it be Google's router. Now the Google will have a server here, right? This is the Google server. Okay, now so this is called, or say, let me draw it here. Let me draw with, to the left side we have our network, this is our network, or this is our area, or this is the private. Yes, exactly, this is the private, or you can say it's not really again private, it's inside, it is inside to our organization. So this is the inside network, this is the inside network. Okay, yes. Now here you got, so to the right side of the line you got outside network. So these are the outside network, outside of our organization. So this is outside, inside and outside network. Now when you communicate to internet, so you might have heard of it. To communicate to internet we need public IP, public IP. So there are two types of IP address, let me tell you. So first is called private IP and the second is called public IP. So private IP you can use any IP, you can use any IP in the sense you got a specific range of IPs. So the class A you got 10.0.0.0 to 10.255.255.255. This is the private IP. Now for class B you got, say, the 172.16.0.0 to 172.31.255.255. This is the private IP range. Now for class C you might have heard of this address, 192.168.0.0 to 192.168.255.255. Yes, mean, say these are the these are the private IPs. It's not really a single network here, right? So you can subnet it. Suppose this is, here you got the entire 10 here. If you're going with the classless, here you got multiple subnetwork or the network here. So now again here also you got multiple network here. Okay, so this is these are the private IP address range. These are the private IP range and rest are the public. Rest are the public IPs. Private and public. public IP. The rest IPs are completely full public IP. Okay, so these are the only private IPs and the rest will be completely public IP. Now, so the private IP, so we will be using inside our organization, we will be using the private IP. Okay, so that means here, so suppose this is the private IP. The entire thing here will be private IP. Okay, now, so here we will be using the private IP. Suppose that I am using 10.0.0.1, 10.0.0.1 here. And suppose this is 10.0.0.2 and this is 10.0.0.3. Now, when you want to communicate to internet, you need a public IP. You need a public IP, which will be provided by the service provider. Suppose that you have taken a connection from the Airtel. The Airtel will provide you with a public IP. Okay, so here the public IP, suppose the public IP here is 1.1.1.1 at your end. Okay, your end, suppose it is 1.1.1.1. Now, then again, this is the Google. This is Google. So suppose the Google is having the IP. We really don't know the IP of Google, right? So suppose the Google is having a public IP. So this is suppose 2.2.2.2 is the public IP. Okay, now they will also have an inside IP address. Okay, inside IP means the private IP. They will also have a private IP. Suppose the private IP is say 10.1. Or suppose 172.16.0.1, and here the IP is 172.16.0.2. Clear? So this range or this our private IP is called inside local address. It's called inside local address. Local means private address. Local address refers to the private address. Now this IP at our end, the public IP at our end is called inside global IP or inside global address. So we have inside local address and inside global address. Inside local means our network itself or our company network itself, we got private IP. So that's the inside local IP. Now inside global IP means it is our IP only that we may be getting from the service provider, but that is public IP. Clear? Similarly, this address here, it is called outside. With respect to our organization, it's an outside one. So outside global address. This is outside global address. 2.2.2.2 is outside global address. Now these IP 172.16 IP, these are outside local address. Outside local address. Clear? Okay. So now let me tell you. So here, when you are trying to communicate, to the internet, when you are trying to communicate, suppose this, say 10.0.0.2 is trying to send something to the Google server. Okay, so when you are trying to send, you can access only up to the outside global address, or their public IP. It is accessible, or say only their outside global address or the public IP address is accessible to us. The other is a private one. The other and 172.16 is a private one. We don't need to, or we don't have to say know their private IP. That needs to be kept private. Getting it? Similarly, our private IP also, we need to keep it as private. Nobody should be knowing our private IP. Okay, so what we will do is that, so whenever this machine 10.0.0.2 is trying to communicate to 2.0.0.2, when he is trying to communicate to 2.0.0.2, so only up to here we are able to say send the packets. Okay, so when we are trying to send it to 2.2.2.2, let me tell you what happens. So the packets will be sent to our gateway, which is router, and what the router will do is that he needs to convert this IP. Convert this IP means the private IP, he needs to convert it. Okay, so the packet was previously having the source IP as 10.0.0.2. Now the destination IP, it is 2.2.2.2 only. Okay, now When it reaches the router understands that some private IP is trying to communicate to the public network. So what this router will do is that we will configure, we might have configured something called NAT here. So he will convert this IP. He will convert this IP to public one. Okay, suppose he'll be converting, suppose that he's converting to 1.1.1.2, some public IP. Okay, so what happens is that, say, the private IP gets converted to the public IP. Okay, and will be sent to the Airtel router, and again will be sent to the Google. So the Google server will be replying back not for 10.0.0.2 but for 1.1.1.2. So will be forwarded to the router, and our router, so what our router is doing, it is translating the private IP to the public. And once, say, the packet is received here, he will convert the public IP back to the private. So that process is called NAT, network address translation. Clear? Okay. Yes.
So the service provider has a lot of public IPs for it.
Yes, exactly. They have lot of public IP. Okay. So did I tell you the hierarchy here? Okay.
About data communication. About the service provider.
Yes, that hierarchy, right? How the IP address is getting, right? So the IP address we are getting from the IANA. The IANA will be assigning /8 and all, and the RIR will be assigning to ISPs. They will be assigning /16. So there you have 65,534 IPs and all. Okay. So again they will be assigning a lot of IPs to the and other service, say the secondary service provider, the tertiary service provider, like that. Okay. So they have a lot of. Now again, let me tell you. So nowadays, the IPv4 public IP has been like almost exhausted. Okay, and so we are going with some concept called IPv6, which we'll study in the next class. Okay, now Subhash has a doubt. Why should it get converted? Okay, why should it get converted here means, so here, if it is not getting converted, okay, so suppose this is Deva's company. Deva's company is also using a private IP. Now, my company is also using a private IP. Say my company might also use the same private IP. So it will get a clash. Right? So the private IP needs to be converted to public IP so that it can be converted, or it can be, say, communicated to internet. If at all you are sending something, with a private IP you are sending something, that will not be routed. That is not routable in the internet. Clear? Okay. Now, done, guys? Okay.
So the service provider will providing us a public IP address.
Yes.
And how will we convert it into private IPs for our home network?
That automatically the router will do. Okay. So this translation we will configure it. We will configure our end here, the inside the private IP end and the public IP end. We will configure it. Okay. And we will do the translation. No worries, you'll understand it. Okay, you will be configuring those things, how the translation needs to be done. Okay.
Does public IP have a class also, sir?
Public IP doesn't have anything. Say public is, say they have class. IPs always have a class. IPv4 always has a class. In the classes itself, you got, again, we have divided it into class A, B and C, right? So again, yeah, you can say 1 dot is in class A, but nowadays we are going with a classless address only because it is already subnetted. 1.0.0.0/24, 2.0.0.0/24. These are now classless. Okay. Now we'll be studying the NAT here. There are different types of NAT. Okay. So what we are studying, say you can translate the source IP, you can translate the destination IP and all, but our, say, study will be limited only to the source IP translation. Okay. Now, so our study in NAT can be divided into two. One is called static NAT, and the other is called dynamic NAT. Static NAT and dynamic NAT. Static NAT and dynamic NAT. Now this static NAT, obviously you know what is static and dynamic, right? In static we will mention each and every translation command. If you got 100 machines, we will mention the 100 commands there. So this IP, this private needs to be translated to this one, this private needs to be translated to this public, like that. We will mention the 100 commands. So we will configure the NAT manually, manual NAT configuration or manual NAT assignment. Okay. Dynamic NAT, the NAT address or the NAT entries are automatically provided by the router itself. Address assignment by the router. By a router itself. Address assignment by router itself. Okay. Now we'll study both static NAT and dynamic NAT. Okay. So now here static NAT. So now done. Okay. So now again let me now tell you. So first static NAT. So let me just configure a figure here. Suppose you got R1 router. Okay, this is our router. Now this router has got a switch here and we got some computers here. Suppose this is here, it is 10.0.0.1, okay, the router IP, and suppose this is .2, .3, .4, .5, .6, etc. So now here we want to communicate to the service provider R2, and here we got the Google server here, suppose. So everything is public here in the service provider. So now suppose it is say 1.0.0.0/24 network, 1.0.0.0/24 network. Here we got .1 and here we got say 250 or 2.2 here. Okay, so now here we suppose we got 2.2.2.0/30, okay, .1, and here it is 2.2.2.2/30, suppose. Okay, now here we will be mentioning the NAT here. We'll be mentioning the NAT or the static NAT here. So the static NAT will be mentioned here, and I told you the static NAT says we will manually configure the private to public mapping. That means if at all 10.0.0.2 is trying to communicate, change this IP to 1.0.0.3, which is a public one. Now if at all 10.0.0.3 is trying to communicate, change this IP to 1.0.0.10. Okay, now if at all 10.0.0.4 is trying to communicate, change this IP to 1.0.0.100. .5 is trying to communicate, its IP needs to be changed to .250. And if .6 is trying to communicate, change this IP to .253. You can mention, yes.
How will we know that this is the public IP that we need to configure?
We will be having a set of public IP here. Here we are having a set of public IP 1.0.0.0/24. It's already there, and that's why I'm configuring this public IP range. Okay, now so here we are gonna configure that. So let me just take the packet tracer and give me a moment to configure all the IPs here. Okay, so first let me create a topology. So yes, let me take a router first. And let me take some computers also. Say we got a switch, and let me take some computers. 1, 2, 3, 4, 5 computers. We have 5 computers now, right? Okay, so now let me connect it, and again let me take another router, the service provider router. Okay, so now So this is the service provider router, and from here we have connected a server, suppose. Okay, now let me just connect it. Okay, just give me a moment. Options, preference. Okay, so now yes,
And the concept from the server to router, why is it crossover?
it's, why is it? It's crossover means, say here we got the Ethernet, right? Ethernet, the LAN only. So there we'll be going with the crossover. So here the server is a DT and the router is also a DT device. I suppose I might have told you about the DT device, right? Yes or no? DT device, data, yes, DC and DT. Okay, DC device means data communication equipment device, and DT device means data terminal equipment device. Okay, and DC, say, sorry, DT means we'll be having, say, I might have told you, right? What do you say? The first pin is transmit pin. Okay, the first is transmit, the second is transmit minus, the third is receiving, and the sixth is receiving minus. In both the end, it's like that. So that's why you're gonna give crossover. Okay, nowadays they have auto MDX feature, which will be like, even if you give the reverse cable also, it's gonna work. Okay, now, so now let me tell you here. So let me just configure it, say, faster. So let me give this IP. So here the IP is, so let me take the notepad, that would be fine. So here serial 0/ just give me a minute, 2/0 2/0 faster and 0. Okay, so here so now let me mention interface faster and 0/0 in router 1. I'm going to give the IP address 10.0.0.1 255.255.255.0. then let me give no shut also. Okay, and gonna configure that in serial interface serial 2/0. then I'm going to configure IP address 1.0.0.1 255.255.0 no shut. Okay, this is the R1 configuration. So let me do it. Okay, now let me just do the R2 configuration as well. So in R2 this is 2.2.2.1/30, so it's /.252. okay, sorry, no shut, 252, yes. Now in serial 0/2/0 it is 1.0.0.2. so now let me go to R2 here. Yes, config T, it's configured now. Okay, so now, and let me configure the computers as well. Say here the IP is 10.0.0.2, okay, /24, so 255.255.255.0, and the gateway is 10.0.0.1. okay, so 10.0.0.1, and the next one is 10.0.0.3 255.255.255.0, then 10.0.0.1. okay, the gateway. So now 10.0.0.4, the same thing, and 10.0.0.1 and 10.0.0.5 here. And suppose we got 10.0.0.6 also. Okay, I'm not configuring that. So now here the IP is 2.2.2.2. okay, and /20 255.255.255.252/30. okay, and 2.2.2.1 is the IP here, IP of the gateway. Now, so the pre-configs have been done, the pre-configurations have been done. Now, so now what happens is that, let me now tell the router to do the NAT here. We are going to do the NAT in our router, shall we? Okay, we are going to do the static NAT. So what we are going to, so here this is the table. So 10.0.0, so the private IP and the public IP here. So what I'm going to do is I'm going to go to the router and I'm going to mention the command like that. So Ip Nat inside, we are going to change the IP of the inside address. Okay, Ip Nat inside source, we are going to change the source. Now source, now we are going to statically change it. Now we'll mention the inside local address and the inside global address, say private and the public IP. So now we'll mention the inside local address, the private IP, and the inside global address, which is a public IP. So 10.002 needs to be converted to 1.003. So we'll mention that. So here we will mention the inside local IP, which is 10.002, then the inside global IP, which is 1.003. That's it. Okay, then I told you we are doing the static NAT. So we have to mention for all the machines here, we have to mention the commands manually. Okay, so again the next command, what does the next command say, or what is the next one? 10.003 needs to be converted to 1.010. So we'll change it. Okay, so we'll 10.003 needs to be converted to 1.010. Okay, then 4 to 100. So here 4 to 100. And what about 5? 5 to 250, 6 to 253. Okay, so 5 to 250. 5 to 250 and 6 to 253. 6 we can configure, just giving the IP, right? Okay, that I didn't configure because I felt lazy. Okay, because you were waiting, so I didn't give it. If at all you want, you can give it. Okay, sorry, 10.006, sorry, 10.006, 255.255.255.0, then 10.001. Now is it okay? Yes. So now, so here we are done the configurations manually, but still it's not complete. Let me tell you. So here we have done the configurations by the static NAT, we have done it manually. If you have 100 routers or the 100 machines, you are going to give the 100 commands here. That's the static one. Now let me tell you. So now again, so here we know the fastnet 0/0 is the inside network. It is the inside network. So inside network means it's going to be, or what you're going to do is you're connected the private IPs here. That's the inside network. So we'll mention F0/0 as the inside network. So we'll go to F0/0. Interface FA0/0. Well, I'll mention IP NAT inside. I'll mention IP NAT inside. Okay. Then now we know this serial 2/0 is the outside. We'll configure that also. So we'll configure serial 2/0. So interface serial 2/0 as IP NAT outside. Clear?
It's inside public.
Inside?
It's inside.
Yes,
public.
it's the inside public. Inside public means inside global address, but from that you are connecting to the outside world. That's it. Okay. Now, one more thing you need to specify. One more thing is that you are gonna give the default route. You're gonna give the default route. So if at all any packet for the Google comes, it needs to be forwarded to the service provider. So we'll give the default route. So we'll give the default route here like this, and let me just give me a minute, guys. Okay. So we are gonna mention the command is IP route 0.0.0.0 and again 0.0.0.0. Then we'll give the next hop IP, or you can give this one as well. Okay, either you can give the next hop IP or you can give the exit interface, which is serial 2/0. You already know it, right? Yes or no, guys? Yes or no? Sure. Okay. Now, Anish,
Why 0.0.0?
I have taught you the default route, and if you ask me Want it? Now, so serial 2/0. Now, tomorrow remind me to ask him, say, tomorrow I should get the answer from you. Why? Yes, why I have given 0, 0, 0, 0. Okay, remind me, you guys. You three will remind. I'm sure of that. Okay, now. Okay, so now, so here we have mentioned the default route also. So what happens is that, let me tell you. So here, when this machine is trying to communicate, so give me 1 minute. Epic pen. Where is it? Okay, so now, so if at all this machine 10.002 is trying to communicate to outside world, or 10.002 is trying to communicate to Google. So first the packet will be sent to the gateway, which is the router 1, R1. Now from R1, let me tell you, so R1 is getting the packet from the inside network. He's getting the packet from the inside network. And he will check the packet. It wants to go to the outside network. It is unknown to him. It is unknown to him, and for all the unknown, we have just mentioned the default route. It should be passed, or it should be, say, traveled, or it should be like sent out through the outside interface, serial 2/0. So that means from the inside network, it is trying to go to the outside network. Getting it? So from inside network, if somebody is going to the outside network, say you got the NAT table configured, the NAT configured here. So it will check the NAT table. So he'll check the NAT table, and it is mentioned 10.002. If at all he is trying to communicate from inside to outside, his IP needs to be converted to which IP? Which IP? 1.003. Sure?
Yes.
Okay. Now, so it will be converted to 1.003. So the packet, the source IP of the packet will be changed to 1.003 and will be sent to R2. And will be sent to R2. Now R2 will receive it, and R2 will receive it and will send it to the Google, because the destination is 2.2.2.2. Okay. Now it will send, the server will send back. While server is sending back, the source IP will be the server's IP, which is 2.2.2.2. And what will be the destination IP, guys? 1.003 will be obtained in R2. And R2 has directly connected 1.network. He will send it through this network, and the router receives it. And when the router receives it, he will receive it for 1.003, which is actually for 10.002. So the router will convert it back to the private IP. Private IP. Clear? Then it will convert it back and will send it to the correct machine. Clear, guys? This is what that happens. So let me ask you one thing. Is it necessary? So R2, for R2, this 10 dot network is unknown, right? So shouldn't we mention the 10 dot network to R2, guys? No. Why? Why is it?
Because when it's coming,
why is it?
We are trying to keep it private.
We are trying to keep it private. So what? Yes. Yes, Ashwin. Ashwin was telling something. Yes.
So we don't want to disclose.
We don't want to. We don't want to disclose. Then how will it send the packet, guys?
when it's coming out from the serial flow, the network is 1.0. So it's 1.0 is already directly connected to the R2, so there won't be any.
Exactly. Very good. Right. Okay. So now, sorry. Okay. So now, so what happens is, yes, of course, we are trying to make it private. How? By translating the IP to the 1 dot network. So while getting the reply back, R2 doesn't need to know the 10 dot network. It is private. It is sending the reply back to the 1 dot network only, not the 10 dot network. Getting it? So for 1 dot network, it is directly connected. So R2 knows about 1 dot network. He'll send it to this route. Clear? Okay. So this is how it works. Now, after doing the config, we haven't checked it, right? So let us check it. So we will try to ping. We'll try to ping to 2.2.2.2. When we are trying to ping, we should get the reply. We'll check it whether we are getting the reply or not. Okay. Yes, we are getting the reply from 2.2.2.2. Okay. So this is how you're going to do the NAT. And let me just show it to you. So if at all I ping from another computer here, ping suppose 2.2.2.2. It's also pinging. Clear? Now, if I take this one, so this router, I told you, it will get, or it will convert the public to private or the private to public. So it will convert it and will maintain it in a table called NAT table, which can be viewed like this. So Ip Nat Translations. When you check it, you can see whenever this machine 10.0.0.5 is trying to communicate, his IP is changed to 1.0.0.50, 250. And whenever the machine 10.0.0.2 is trying to communicate, his IP is changed to 1.0.0.3, which is mentioned like this. Say whenever 10.0.0.2 is trying to communicate, his IP is changed to 1.0.0.3. And whenever 10.0.0.5 is trying to communicate, his IP is changed to 1.0.0.250. Getting it, guys? Okay. So this is how the NAT works. Static NAT works. Now, shall we discuss about the dynamic NAT?
Yes.
So before that, can you show me commands?
Sure, no issues. Okay. So the commands, these are the commands. Show history. Oh. Do show history. Unfortunately. Okay. So now let me show it to you here. So this is these are the commands. Let me copy. Now again, we have not done yet. Okay. These are the commands. You don't need to write these rconfig every time. Okay. Just a moment, guys. So guys, to view the translation table, the command is, we'll go to the privilege mode and the command is show Ip Nat Translations, NAT table. So now guys, now we'll do the dynamic routing. So to do the dynamic routing, let me take away all the static routing config. Okay, so let me take away the static routing concept in config, in the sense we'll be like taking away, or we'll be just giving the no to these commands, the static entries, but we'll have these configs retained, the inside network, the outside network config, and also the routing, the default routing concept will be retained there. Okay, so here let me give no to all these static NAT commands. Sorry. Okay, so now that I've deleted all the static NAT commands, if you check the NAT table, do show Ip Nat Translations, it's empty. Okay, now we are going to give the dynamic NAT commands. So dynamic NAT commands, let me tell you. So previously we have mentioned the inside local address and the inside global address. For each local we have inside mentioned the each global address. Now we are not mentioning it like that. So together we will mention the inside local address using something called ACL. Using something called ACL, or we will use a reference ACL. We'll use reference ACL. Reference ACL is just to represent these addresses. It's not that you will bind it to an interface. We will not at all bind this reference ACL to an interface. We are just gonna match the traffic. That's it. The only purpose of this ACL to match the traffic, nothing else. Okay, so where we will use the permit and all. To match the traffic, we'll use permit. So now, then the inside global address will be represented. The range will be represented using something called pool. Using something called pool. So this is the first step. We'll mention the reference ACL to represent the inside local address. The second step is to mention the pool to represent the inside global address. And the third says we'll bind them together. That's it. We'll bind them together means we will mention them together. If at all, say an address or an IP from the reference ACL is trying to communicate to outside network, change the IP, the source IP, change it to any IP in the pool. Clear? We are not mentioning this IP needs to be changed to this particular public IP. We are not mentioning like that. That's the dynamic NAT. Clear? Okay. So to do that, let me tell you, here we are going to create a reference ACL. It can be, say we are going to create the standard ACL here. It can be standard ACL, standard numbered or named. So let me create a numbered here. So access-list 10. Okay, then let me permit. So here the local address is 10.0.0.0/24. So what we are going to mention is, we are going to mention the IP 10.0.0.0, then the wildcard mask is 0.0.0.255. Okay, for the entire network we have mentioned it. Clear? Now we'll create a pool. The command is Ip Nat pool. Then suppose we'll give a pool name. Suppose we are giving test. Then we'll mention the pool here. The pool can be starting, or it can start from 1.0.0.3 because 1.0.0.1 is already used and 1.0.0.2 is already also used. So it can start from 1.0.0.3 onwards. To which IP? To 1.0.0.254. Clear? We got a range of IPs which will end in 1.0.0.254. Clear? So now we are going to mention the starting IP and ending IP. So the start IP which is 1.0.0.3 and the end IP which is 1.0.0.254. Clear? Then getting it? Okay. Now we'll mention the command or the keyword net mask, and then we'll give the subnet mask which is 255.255.255.0 because here it is /24. So we have mentioned it like this. That's it. Done. So what happens is that if at all any IP address from this access list, if at all any IP, I mean any machine from this access list is trying to communicate to the outside network, it needs to be translated to the IP, to any IP mentioned in the pool. Okay, so now let me try to communicate from 10.0.0.2 here, or any computer. So now I'm trying to communicate from this computer, ping to 2.2.2.2. okay, so here let's see whether it's pinging or not. No, what happened? Okay, let me check, guys. It's not pinging.
We didn't bind it to
Yeah, we didn't bind it, right, guys? So one thing we forgot. So the first thing we have, the first step we have done it. The first step said we have to mention, say again, let me minimize it. So the first thing said we have to say create a reference ACL, and the second thing said we have to create a pool. But did we bind it together? No. So let me bind it here. So the binding command is like this. Say again, we'll go to the router. So the command is Ip Nat inside source list. This is the command, Ip Nat inside source list. Then we will mention the list number here. So here we have created a numbered ACL, or if at all it's named ACL, you can mention the name also. Okay, here the ACL number is 10. So here we'll mention the list number 10, and the pool is test. So we'll mention test. That's it. So if at all somebody from the list 10 is trying to communicate outside, we'll change the IP to any IP in the pool. Okay, pool test pool. So now again, if you try to communicate, okay, you are getting the communication. Okay, now again, if at all I'm trying to communicate from this machine, this also communicating. Now if at all I'm trying to communicate from this machine, ping 2.2.2.2, it is also pinging. Now if I check the NAT table here, show IP NAT translations, you can see whenever 10.0.0.2 is trying to communicate, his IP is changed to 1.0.0.3. Whenever 10.0.0.5 is trying to communicate, his IP is changed to 1.0.0.4. And whenever 10.0.0.6 is trying to communicate, his IP is changed to 1.0.0.5. It is done automatically. We didn't mention anything like this. So we didn't mention when 10.0.0.6 is trying to communicate, it is we didn't mention that it needs to be converted to 1.0.0.5, but it is automatically translated by the router. Clear? Okay. So this is the dynamic. Yes.
So what are the numbers represented after the colon?
That we'll study later. These are the port numbers. Okay. Yes.
Sir.
Yes.
In this wildcard match, we use 0.0.0.255. But in the yesterday's ACL, for single letter, we use 0.0.0.0.
It's now here we have mentioned 0.0.0.255 because we want to represent the entire network here. Okay, not for a group of machines, not for a single machines. We are representing the entire group of machines here. Clear? Okay. Now guys, so this is how we will do the, say, dynamic routing. Okay, so if you want to take a note of the commands, you can note it down. So let me just do show history. Okay, so these are the commands here. So these were already there. Okay, it was already there. So these are the dynamic NAT commands. Okay, these three. And guys, this should also be done, as we have already done it. I'm not doing it now. Okay, the default route, the inside network and the outside network, mentioning these things. Now guys, now let me tell you. So in the real time, so somebody has asked, I suppose it was Anish, right? Okay, so here how will you understand, or what are the public IP? So here I told you the public IP can be understood like this. Say we got a range of IPs here, but in the real time our company won't be purchasing all the IPs here. Here how many IPs you got it here? Here you got 254 assignable IPs. In the real time we are not gonna purchase all the 254 public IPs even. So public IP is very costly. So we are not gonna spend, say again, 254 IPs we are not gonna buy. So we will be buying maximum 1 or 2, maximum 2 IPs. That's it. We are gonna buy only maximum 2 public IPs. So suppose that we only have bought one single public IP. Then the address here will be like this. The available IPs, say it is 1.000/30. It is 1.000/30. So that means you have 1 here and .2 here, and .3 is a broadcast, you can't use it. And .4 is in some other network, you can't definitely use it. Okay, so you only have a single address at your end. You only have a single address at your end. So what you're going to do is that in the real time, say whenever 10.002 is trying to communicate, whenever 10.002 is trying to communicate to internet, their IP will be converted to 1.001 itself. Okay, now whenever 10.003 is trying to communicate, their IP will be changed to 1.001 itself. Whenever 10.004 is trying to communicate, again their IP is also changed to the same IP, 1.001. Again 10.005 tries to communicate, his IP is also changed to 1.001. When 10.006 is trying to communicate, his IP is also changed to say 1.001. Clear? Any doubts?
No.
Sure? Then let me ask you a question.
I have a question.
Before that, let me ask you a question. How will they differentiate? If at all, every one is translated to 1.001, and suppose you are receiving a packet destined for 1.001, how will they differentiate, guys? Now you can ask the question. Yes. Yes, Deva. Sorry?
Suddenly.
Oh God. Okay. Whenever you get like it comes to your mind, you can ask me. Okay. So it means as you are told that you don't have any doubts. That's why I just usually the students will be having the doubt. Okay, like this. As you didn't have any doubts, I thought of asking you that. Now, so if at all 10.002 is converted to 1.001, let me tell you. Okay, they have something called port numbers. Port numbers. So whenever 10.002 is sending something, they have the IP. The packet will be having the source IP and the destination IP. Now the transport layer has the source port number and the destination port number. So suppose the source port number here is say 1000 or suppose 2000. Suppose the source port number is 2000 here. Then the IP here is definitely it is converted to 1.001, but the port number here will be 2000. Okay, now if so whenever he is sending the packet, he is sending with a port number. Suppose the port number is 3000, then the port number will be 3000 here. Suppose the port number is 4000, then here the port number is 4000 here. Suppose here the port number is 2000, then here it will be say suppose 5000. Suppose the port number is 3000 here, then the port number is suppose 6000. Just randomly taking some port numbers, that's it. Okay, so whenever he receives a packet destined for 1.001 with a port number of 4000, it will understand, or the router can understand that it belongs to 10.004 with a port number of 4000. Clear? Now whenever he receives an IP destined for the port number say 3000 or say suppose 6000, so now the router knows that okay, it needs to be converted to IP 10.006 with a port number of 3000. Clear, guys? This is how they will differentiate. So here this is how the real time, okay, the real time things. So again let me tell you, this is called PAT. This is called PAT, or port address translation. Port address translation, which is used nowadays. Okay, port address translation. Port address translation. Now let me tell you, so that is why, so if at all, suppose we got Sajin, we got Ashwin, we got Susmit, and we got Anish. Okay, suppose we got Deva as well. So now suppose they went to Ashwin's home. Suppose they went to Ashwin's home, and everyone has started using the Wi-Fi. So Ashwin is having a Wi-Fi internet in his home. Okay, so everyone started using the Wi-Fi. Now, so suppose Wi-Fi, or suppose they started using the internet here. Okay, they started using the internet. So everyone here will be having different IP. Suppose this is 10.00 or 192.168.10.1, 192.168.10.2, 10.3, like that. Okay, so here suppose it is 1 here, .1, .2, .3, .4, .5, and .6. Now, what Sajin did, suppose he just sent a mail. He just sent a mail. Say just a example. Okay, he just sent a mail. Okay, so he just sent a mail to, say, suppose CM or PM. Something anonymous he is sending, and he has like, he just wanted to like send a message. That's it. Just he was just joking. But okay, suppose he has sent that, okay, today so and so bomb or something has kept. Okay, then who will be caught? Ashwin will be caught, because the internet connection is in Ashwin's name, right? Because he has, so the service provider, so again the mail, so the police can track in which or from which IP this mail has come, and that is the public IP, not the private one. That's the public IP, and that is unique. So at that time, suppose say April 1, say 2022, suppose today is April 1, and Sajin has like thought of like making April 4. Okay, that was his plan, but unfortunately what happens is that, say today is April 1, and by 6:35, say we got a public IP, suppose 8.240.21.21, one public IP. So the police will track, okay, the mail has been received from this IP, this public IP, and he is the only person using that public IP at that time. So it is already registered in the ISP. Okay, it'll be there when you check the ISP. Okay, the ISP will tell, okay, this address is registered with this IP at this time. So Ashwin will be caught at that time. Clear, guys? That's how the IP, so that's how the police track the IP. So the public IP is unique, while the private IPs, it can be, say, it can be same. If at all we are using internet from Ashwin's, or we are using the internet from my office or my home, so we'll have the private IP same for everyone, but the public IP will be different. Getting it? Okay. Now coming back, guys, again. So where were we? PAT. Yeah. So now doing the PAT configuration. So here this is the PAT. Now doing the PAT configuration, let me tell you, you only have, say, a simple changes here. So first let me change the topology here. Let me change the topology, because we were having IPs 1.0.1 and 1.0.0.2, both are /24 here. So let me change to /30 here. Shall I?
Yes.
Okay. So now, so here interface serial 2/0 IP addresses 1.0.0.1, suppose 1, 255.255.255.252. Okay. Now again, yes, no shut is already given and it's up. Do show IP interface brief. You can see it's already up, and we don't need to give the no shut again. Okay. Now let me give the IP interface serial 2/0 IP addresses 1.0.0.2, then 255.255.255.252. Okay, change the required IPs and all. Okay, now that we are gonna give So where is it? Okay, the configuration. So let me take away the old config. Let me take away the dynamic NAT config. Okay, so if at all we want to take away the dynamic NAT config, let me take away this first. No. So now let me paste it. Okay, now only some small changes are there. Okay, so now if you check do show run, you do not have any NAT configured, only the interface is configured with the NAT and all. Okay, we do not have any globally configured NAT. Dynamic NAT has taken away. Okay, or just reconfigured. Now, so we will hear the same thing. To represent the inside local address, we'll be using the ACL, and to represent the inside global address, we'll be using the POO. But the starting IP and ending IP, we only have a single IP here. We only have a single IP here. The IP is 1.0.0.1. So the starting IP is 1.0.0.1 here. Okay. Now the ending IP is also 1.0.0.1 here. Clear? Okay. Now the subnet mask is 255.255.255.252. Then we are going to give an additional thing here, overload. We are going to give the additional keyword, which is overload. Okay, so let me configure here. Okay, if you have configured this much, let me tell you what happens. So now when I try to ping from these computers, ping 2.2.2.2, you are able to ping to 2. Now if you try to ping from this computer again 2.2.2.2 is pinging. Now if you try to ping from this computer again, say here 2.2.2, everyone is pinging. Now let me check this one. Okay, the NAT table. Show IP NAT translations. You can see whenever 10.0.0.5 is trying to communicate, his IP is changed to 1.0.0.1. Now whenever 10.0.0.2 is trying to communicate, his IP is also changed to 1.0.0.1. Whenever 10.0.0.3 is trying to communicate, his IP is also changed to 1.0.0.1. And you can see the port numbers. Here the port number 10, so it is converted to 10. Now the port number is 19, its port number is converted to 19. Again the port number is, say here 10.0.0.5 with a port number of 9, it's being converted to 1.0.0.1 with a port number of 9. So this is how. So whenever he receives a packet destined for 1.0.0.1 with a port number of 9, the router knows it is 10.0.0.5 with a port number of 9. So he will translate the IP. Clear? Any doubts?
No.
Okay. Yes?
Port numbers are assigned randomly.
Yes.
And is there a limit for them?
Of course, the port numbers here. So port numbers are 16-bit values, and the value can be from 0 to 65,535. Okay. The source port numbers here are random, while the destination port number, let me tell you, you got well-known port numbers and all, right? You might have studied the port number 80 for HTTP, for say 2021 for say FTP, like that. Okay. So these are the port numbers of the machine which can be random. Clear? Okay. Yes, I'll give you. Okay. So now, where's the pad command? So this is the pad command. So again, remember, we have to do the inside NAT configuration, outside NAT configuration, and also this one as well. Say, what do you say? The default route also. Okay, that needs to be done in addition to these commands. Clear? Now guys, so this is the PAT, port address translation. Now so we are done. Okay, ACL and NAT we have done it. Now was thinking, so do you need a break?
Yes.
Okay, then we'll give you a break because today's portion is completed and then we'll go with the next portions, some theory portions. Okay, so we'll complete some theory portions. We have, so yeah, we haven't taken this portion, right? BPD, port fast and BPD card, port security and either channel FT card. Okay, so we'll go with the port fast, BPD guard, and then after that we'll go with these theory topics also. Okay, by that time it will be almost our time. Okay, yes guys. So we'll get back at 7:51. Sorry, 6:51. 6:51 p.m. So guys, now we'll study first port fast. Okay, so you can write the heading port fast. So now suppose you got a switch here. Switch. Now a switch is then connected to a computer. Now this computer, you can see when I connect it, it will take, you guys know, it would take some time for this interface to come up. It will take 30 seconds for this interface to come up, right? So what happens is that this switch will be running the spanning tree here. It will be running the spanning tree and it will make this as the designated port. So that's why the delay. So there is actually no, or there is no necessary, or it's not necessary to run the spanning tree here in this interface because we do not have any switches here. We only have a single machine, or we only have an end device connected to this one, right? So there is no necessary to run the spanning tree and all. So if it is in the blocking state, or if it is connected, we can directly move it to the forwarding state. We can directly move to the forwarding state by bypassing the listening state and the learning state. Clear? So we can do that. We can do it by using the configuration called port fast. Clear? Yes. So now again, if at all I disconnect it again and try to connect it again, you can see it will take some time. Okay, it's still orange and it will take some time. So now if at all I configure the, so now if at all I take the command show spanning tree, it's still in listening, still in listening. Now it has become learning state. Again 15 more seconds to become the forwarding state, right? So now to configure the port fast, I'll go to that interface FA0/1. Then we'll mention the command spanning tree port fast. This is the command spanning tree port fast. So if you mention this, then you can read it. Port fast should only be enabled on the ports connected to a single host. Connecting hub, concentrator, switches, bridges, etc. to this interface when port fast is enabled can cause temporary bridging loops. Use with caution. Clear? Okay. So this is why. So now if you disconnect it and if you connect it, it has immediately become up. If you take this, the command do show span, you can see it has become the forwarding state. It will directly become the forwarding state by bypassing the listening and the learning state. Okay, that is the, what is it, port fast. Okay, now you got one more thing called BPD guard. It's called BPD guard. So BPD guard is also configured to the interfaces connected to the end devices, because to the interfaces connected to the end devices we do not expect a BPD. If at all somebody connects a switch, then only the BPD is sent. So we do not expect a BPD, we do not expect a switch to be connected on this interface. So if at all a switch is connected, or if at all a BPD is received, then the BPD guard will guard this interface from receiving the BPD. Means if at all the BPD is received, then the interface will be made down. The interface will be made to error disabled state. It will be made to error disabled state. Shall we check it? Okay. So now, so first let me configure So interface FA0/1. We'll go to this interface and we'll mention the command spanning -tree Bpd Card enable. This is the command to enable the Bpd Card. Spanning -tree Bpd Card enable. Okay, so if you enable this, or if you give this command, let me tell you. So if at all a switch is connected, so again let me delete it and let me connect it. Sorry, it will come up and immediately it will go down. You can see, yes, it has went down. So let me show it to you. When you take the switch, you can read some lines here. Received BPDU on FA0/1 with BPDU Card enabled, so disabling the port. BPDU Card error detected on F0/1, putting F0/1 in error disabled state. Clear? So if at all you want to make the interface up, first you need to delete it. Okay, then you need to make sure that the interface is connected to the end device only. Then say suppose we are connected it. Now what to do is that we will make the interface manually down. We'll make the interface manually down, then we'll make it up. Clear? This is how the interface is made up. Okay, now if at all you want to view it, show interface status, I suppose. Okay, interface status will show here FA0/1 is connected. FA0/1 is connected. Now if at all I say, what happens? This interface will go down. Okay, yes, it has went down now. Then again you receive the same message. BPDU is received on F0/1, making it as error disabled state. Now if you check it, you can see F0/1 is in error disabled state. F0/1 is now in error disabled state. Clear? Okay. So this is the Bpdu card. I suppose you have understood, right? Now the next thing, the theory portion. Okay, so WAN protocols, MPLS and Metro Ethernet. So let me just draw a figure here. So here, where is it? So let me take paint and let me just draw. So suppose you got Bangalore branch here. You got a Bangalore branch. So the Bangalore branch, suppose you got router R1 and suppose this is the Delhi branch R2. The Delhi branch R2. Delhi. Okay. Now, so here I told you that we'll be going for the WAN connection here. We'll be going for the WAN connection. So if at all you are going for the WAN connection, we'll prefer the leased line connection. We'll prefer the leased line connection. Leased line. Okay. Now, so again, let me tell you, suppose you got a switch and suppose you got some computers. Suppose you got switch and you got some computers. So here let me tell you, so here this is the LAN, local area network, and here you got a LAN standard. Which is the LAN standard? Ethernet is the LAN standard. Ethernet is a LAN standard used here. Similarly, we got a LAN standard LAN and we use a LAN standard here. Ethernet is used. Ethernet is used. So now if Ethernet is used, whenever you are sending something from this computer to a router, you will be having the packet and the packet will be, say, encapsulated with Ethernet header. Ethernet header and Ethernet trailer. Getting it? Ethernet header and trailer. Feeling sleepy? Okay. Now Ethernet header and Ethernet trailer. So Ethernet is having the source MAC and destination MAC and those things. Now what happens is that, let me draw it for you. Suppose you are having, this is 10.0.0.1 IP and this is 20 or 20, let it be private IP. So here 192.168.10.1 IP. Okay, so now suppose this is 172.16.0.1 IP and this is 0.2 IP. Let me tell you one thing. So here what happens is that whenever you are sending something from this first machine to this second machine, so here in this LAN, the packet will be like this. The source IP will be 10.0.0.1 and the destination IP will be 192.168.10.1. Now this packet will be encapsulated with a header, Ethernet header and a trailer. And this here you have the Ethernet header and trailer, and the header will be having the source MAC, this MAC address of the first machine, MAC of the first machine, MAC 1, and the destination MAC, yes, the destination MAC will be unknown. If at all it is unknown, then they are going to send the ARP and they will get the MAC. Now let me tell you, if it is known to them, or if at all they have sent the ARP and all, they will be using the destination MAC. It is not the MAC address of this computer. It is the MAC address of this router's fast Ethernet 0/0 interface. Getting it? No. Let me tell you again. Okay. So here, suppose you want to go to, so you are now in India. You are now in India, suppose in Bangalore. Okay, you want to go to suppose Australia. You want to go to Australia or Canberra, which is in Australia. So now I suppose Australia's capital is Canberra, right? Sydney, are you sure? No, I suppose it's Canberra only. Okay, whatever. Okay, so now, so here you got Australia here. Okay, now, so you are in Bangalore now, or suppose you are in NH, you are in Networker's Home. So you are taking a taxi. You are taking a taxi. If you are taking a taxi, your intention is to go from India to, say, or Bangalore to Canberra. You are taking a taxi. So to the taxi or to a taxi guy, what will you say? You want to go to, whether you will say you want to go to Australia or whether you will say you want to go to airport. What will you say? You will say you want to go to airport. So your real location, or you are really traveling from, say the from address is Bangalore. Okay, and the to address is Canberra. Okay, now that you have, say, taken a taxi, now you will tell the taxi guy you need to go to the airport. Suppose the Kempegowda International Airport. Okay, the Bangalore airport. Okay, so now that you have reached, okay, that's the name of the airport, don't get one. Okay, now that you have reached the airport, clear? Okay, so here the from address is, say, Bangalore or say HSR or NH, Networker's Home, and 2 is Kempegowda International Airport or Bangalore Airport. Okay, BLR. Okay, now that from the flight, you have the flight. So when you are taking the flight, say again, you are really going from India or Bangalore to Canberra, or say suppose NH, you are really going from NH to suppose that we have an NH in Australia, Networker's Home in Australia as well, suppose. So if the security guys ask from where you are going to where you are going, what will you say? Whether you will tell from NH India you are going to NH Bangalore, Canberra, or whether you will say you are going from India to Australia. What will you say? India to Australia only. So again, so let me change this one. Your real intention is to go from the NH Bangalore, okay, to go from NH Canberra. So when the security guy is asking you, say again the same thing. Your real intention is to go from NH Networker's Home in, say, India or Bangalore to Networker's Home in Canberra. Okay, but when the security guys ask, you will say from where you are going from. Yes, from India. From India you are going to Australia. Clear? Yes. Now the same thing happens here. Now that you have come to Australia, now from Australia you are again, from this airport you are again taking a taxi. So you are taking a taxi, and this time again to the taxi driver, what will you say? You are telling you are coming from the airport, from say suppose Canberra airport. Okay, you are going to NH, say suppose some other place. Okay, they got some street 4 or 5 sub avenue like that. Okay, you are gonna tell that address. So the overall you are traveling from say this NH Bangalore to NH Canberra, but on the way you are telling different places. Similarly, when you are sending the packet, the overall packet says the source IP is 10.0.0.1 and the destination IP is 192.168.10.1. The packet remains same. Getting it? Now considering the layer 2. So layer 2 here says, now in this layer 2 instant or in this LAN local area network, so you are going from machine 1 to the router's fast Ethernet 0/0. Getting it? So the source MAC will be MAC address 1, the MAC address of the machine 1, and the destination MAC will be here, this fast Ethernet 0/0, fast Ethernet 0/0 MAC. Getting it? So only if you have the destination MAC as fast Ethernet 0/0 of the MAC, switch will forward it to this interface, through this interface. Getting it?
Yes.
Okay. Now that the packet has reached R1. Yeah, L3 we'll talk about. Now the packet has reached R1, or no, not the packet. So suppose you have received the information. You just received through L1, the layer 1, through the physical cable you are receiving it through as bits. It will be passed to L2. So from L1 you are receiving it, it will pass to L2. So L2, what the router does is, the router will inspect the packet, or it will check the packet. So he will read the contents of the layer 2 header and trailer. He will remove those things. And he will read the packet structure. So he'll understand the packet is 192.168.10.1, which is connected through R2. So what he will do is that now the packet remains the same. Now he knows that through the WAN link, through the serial link, he has to send it. So he will again encapsulate with a WAN header and trailer. He'll again encapsulate with a WAN header and trailer. So WAN we really don't know. So it might be using some other technologies. Okay, some frame relay technology or some other technologies. So which will not be having the source MAC and destination MAC, but some other features. Clear? Now then it is received to R2. Okay, now R2, when he receives this frame, or he'll receive it via L1, he'll then pass it to L2, where they will check this WAN header and WAN trailer, and they will check these things, and if it is accepted, then they'll remove it, and then we'll pass it to the network layer. Again the IP will be checked, the destination IP will be checked, and he will come to know that this network is connected to fast Ethernet 0/0. Then what he will do, that he will pass it to this interface, where here it is Ethernet header and trailer. So here it is Ethernet standard. So what he's gonna do is he will encapsulate with the new Ethernet header and trailer. So this time you will have the source MAC address and the destination MAC address. The source MAC and the destination MAC. So the source MAC here will be the MAC address of fast Ethernet 0/0, and the destination MAC, if it is unknown, then here he's gonna send the ARP and all. If it is known, then he is gonna keep this machine's MAC address. Clear, guys? Okay, this is what that happens. Okay, so WAN means you got another set of protocols here. Okay, now WAN uses another set of protocols. Let me tell you. So here you have another set of protocol. First set of protocol is called Hdlc. It's called Hdlc. Hdlc means high level data link layer control, or data link control. High level HDLC. Yeah, HDLC. High level data link control, which is a Cisco proprietary protocol. It's a Cisco proprietary protocol. I don't know that whether you have it or not, these things. Okay, now let me tell you one more protocol, PPP, which is point-to-point protocol. Which is developed by IEEE. PPP is preferable because it supports authentication. Okay, this much is sufficient. Okay, so Hdlc and PPP are the protocols. Other, say, some protocols. Okay, again you got some other protocols also. So these are the protocols used in the WAN. Okay, now done. Okay, now let me tell you. So now we are going to talk about something called Metro Ethernet. Something called Metro Ethernet. Okay, so Metro Ethernet or Metro E. Metro E. Done there. Okay, now let me tell you again. So here we were using the serial cable. Serial is of different types and all. Okay, we got different types of serial and all. Now let me tell you, suppose you got router R1 and router R2. So here you are using the gigabit Ethernet. Suppose you are using the gigabit Ethernet. So gigabit means it works at 1 Gbps bandwidth. 1 GB will be sent in 1 second. Now considering the early serial, or suppose you are using the smart serial and all, or the normal serial, which supports 1.544 Mbps. Which supports, suppose the base bandwidth is 1.544 Mbps. Let me tell you. So here it works at 1.544 per second. It only transfers, or it will only send 1.544 MB, which is very slow, right? Then say the engineers or the developers started thinking, why can't we utilize this gigabit, or why can't we utilize the Ethernet standard which is used in the LAN as WAN? Why can't we use it in the WAN also? Clear? So it is nowadays the Ethernet is used in WAN, which technology is called Metro Ethernet. It's called Metro Ethernet. So Ethernet can be used in the WAN also. So now it is no longer a LAN, it can be used in WAN also, and that concept is called Metro Ethernet. Clear? Okay. And again they have given you some theoretical things, you can go that in the textbook. Okay. Now the next thing, Mpls. Next thing is Mpls, multi-protocol label switching. Okay, so Mpls, or it's called multi-protocol label switching. Multi-protocol label switching. Which is an ISP thing. Let me tell you. So it has got two parts: multi-protocol, that's the first part, and label switching is the second part. The first part says it supports multi-protocol, or it supports multiple protocols. It means it supports multiple protocols to connect from the customer end or the customer edge to the provider edge. Okay, it supports multiple. Say you got many different ways to connect from the customer to the provider. So either you can go with a leased line connection, or you can utilize Metro Ethernet. Just now we have talked about Metro Ethernet. Or you can go with some other connections, some TDM, or say like frame relay, whatever. Okay, and DSL connection or ADSL connection, you can go with multiple connections. Okay, from the customer edge to the provider edge. Now from the provider edge, or that is why it's called multi-protocol, we can connect multiple protocols. Now in the provider edge, let me tell you what happens here. Suppose this is the provider edge. In the provider edge, you will have multiple routers. Okay. Now, whenever he is receiving a packet, this provider edge router is receiving a packet, what he will do is that he will encapsulate the packet with a label. The label is inserted between the layer 3 header and the layer 2 header. Getting it? Then it will be passed to the next router. So this router, what he will do is that he will like remove the layer 2 header and the trailer and will read the label here. Instead of reading the packet here, he will read the label and will send it to the next router. Getting it? Now again, so here the labels will be read. Here. Okay, every time, so they will add a label and remove a label. Again, this router will add and remove a label. So what happens is that this label is being read. They will not be reading the packet. So that's what it's label switching. Okay, so this is the MPLS, multi-protocol label switching. Okay, so now MPLS is also called layer 2.5. It's also called layer 2.5 because the label is added between layer 2 and layer 3. Clear, guys? Okay. Now again, one more thing. Okay, so it is called MPLS. Sometimes MPLS is called MPLS VPN. So VPN is a different thing. We'll talk about that. Okay, but MPLS VPN, let me tell you why it is called MPLS VPN. Because here between the packet you are adding some extra headers. Or you are doing some encapsulation. But VPN, the real meaning of VPN is something else. Okay, but sometimes it is called as MPLS VPN. That's it. Clear? Okay. So this is the MPLS. Now, want to study the next topic, VPN, or in the next class? 7:20. Next class. Okay. So we'll go in the next class. Okay. Want to study, Smith? Okay. So then, who all says want to study? No one. Only Susmit. Okay, Susmit will stay back. Others will go. Okay. So this is again theory. Okay, VPN is theory. So we got VPN. It's just a matter of 10 minutes. That's it. But again, we'll go in the next class. Now we are completed. So this is 1 day class. Okay. Then this is the 2nd day class. Then the 3rd day class. 4th day class. So next week we'll finish our portion. Yes. Okay. Yes. So thank you guys. We'll see next week. Okay. Thank you. Happy weekend. Okay.